Hello there, today we will be showing you the easiest, fastest and cheapest method for making sodium chromate. This method does not rely on oxidants like chlorates, nitrates or peroxides. It is a solvent-free solid-state reaction. All you will need is sodium carbonate and chromium 3 oxide. Sodium carbonate is sold as washing soda, pool pH and hardness regulator, food additive, or can be acquired by heating sodium bicarbonate, otherwise known as baking soda. Chromium oxide is sold as a pigment for pottery glazes. For best results you want to mix stoichiometric amounts of the two precursors and then heat to at least 600 degrees Celsius. An easy way to do this at home is with a small Fresnel lens. I am using one that was sold locally as an A4-page magnifier, but they can also be purchased online from AliExpress for $1 each or from Amazon for a little more. As you focus the sun's radiation, the chromium oxide heats up rapidly, which in turn transfers heat to the white carbonate. This gives it sufficient kinetic energy to allow diffusion between the two solids, forming sodium chromate at the interface. In this scenario we have used an excess amount of sodium carbonate, which acts as a crucible to prevent contamination from possible side reactions with the tile. This is also sometimes referred to as a skull crucible method. As the mixture is heated, the sodium carbonate reacts with the chromium oxide and air, producing sodium chromate and releasing carbon dioxide. A consequence of using excess amounts of sodium carbonate is that a low melting eutectic at 650 Celsius is formed between sodium chromate and sodium carbonate, which causes a cascading event where more heat is absorbed from the radiation and better transferred through the melt. This melt at first inhibits the diffusion of oxygen from the air, but when heated further, the agitation produced from the convective currents and release of carbon dioxide counteracts this. Although the magnifying glass method is the fastest and easiest, the same result can be achieved by heating the mixture under a Bunsen burner or placed into a muffle furnace for several hours at 800 to 900 degrees. The resultant product contains mostly sodium chromate with some unreacted sodium carbonate and chromium 3 oxide. The green chromium oxide is easily separated by dissolving the products and decanting or filtering out the non-soluble oxide. The sodium carbonate can be fractionally crystallized out as it has significantly less solubility than the sodium chromate, or it can be neutralized with an acid, or the sodium chromate can be converted to dichromate first. Now you might ask, would this method work starting with alternative sodium sources such as sodium hydroxide or even sodium chloride? The answer we found was actually probably yes. Doing the same with sodium hydroxide does produce some yellow product, but because sodium hydroxide melts at a much lower temperature, the reaction is much messier. Staring from sodium chloride, there is definitely some faint yellow product which might be sodium chromate, but the reactivity appears much lower under the Fresnel lens. Under then Bunsen burner there is no observed yellow product. Maybe this could be optimized in future, but for now sodium carbonate feels like the perfect answer. I hope you enjoyed this. We will be showing some more cool solar-powered reactions, so make sure you subscribe.